Let's take a look at a few more rules of probability. In particular, let's talk about the idea of independence. Now, by definition, two events are said to be independent if the occurrence of one does not change the probability of the other. The occurrence of one does not change the probability of the other. So in other words, knowing that this other one happened had no effect at all on the probability that the first one that we were interested in happened. There's no connection between them. Now, let's talk about a couple of obvious examples that we will not calculate probabilities for, but just conceptually. Event A, my Jeep is black. Event B, I'm married. If you knew I drove a black Jeep, would you also know whether or not I'm married? There's no connection between there. One's independent of the other. Another example. My favorite dinner is a nice juicy ribeye steak, grilled salmon, mashed potatoes with gravy, and hot dinner rolls. My dog likes to eat my rose bushes. That's event B. Now, the fact that I like salmon and mashed potatoes and ribeyes and so forth, does that tell you at all whether or not my dog likes my rose bushes or not? See, there's no connection between them. Knowing one does not tell you anything about the other. That's what we think of when we talk about the idea of two events being independent. Now, consider two arbitrary events, A and B. If A and B are in fact independent, then the fact that B just occurred will not have any effect on the probability of A occurring. That's what I said with the rose bushes and the ribeye steak thing. Mathematically, this is suggesting that the probability of A given B is really nothing more than probability of A. If knowing B occurred told you nothing about the probability A is going to occur, then the probability A given B occurred is just probability of A. This is kind of a nice relationship because that's one way we can use to test for independence. If we can find the probability of A, then find the conditional probability of A given B, if those two values are the same, that's telling you that they're independent of each other. If they're different, then there's a dependence going on. The fact that B occurred, this other event occurred, had an effect on or changed the probability that our initial event actually occurred. Now, the probability of A given B can be calculated by the joint probability divided by the probability of B. This is saying the probability of A and B, that's the joint probability, divided by the probability of B. Therefore, if they are independent, or under the condition of independence, the probability of A and B must be equal to the products, A times B. That has to happen. Why? Think about it. We know that if they're independent, the probability of A and B divided by the probability of B will in fact equal the probability of A, if they're independent. The only way this can possibly happen is if I have the probability of A times the probability of B divided by the probability of B, because now the probability of B's will cancel out, leaving me just the probability of A. So, this is another nice condition that we can use to test for independence. If I can find the joint probability and find the individual probabilities, multiply the individual, multiply these guys together, and if this is the same, this equals the probability, the joint probability, then they must be independent. That's the only way that can possibly happen. So these definitions of independence in conditional probabilities and joint probabilities actually gave us two different ways to check to see if two events are independent or not, provided we can find those probabilities. Now, let's go back to the table that we've been working at and answer this question. Are the events freshman and more than 20 hours independent or dependent of each other? Okay, well, let's see. If independent, then the probability of freshman given 20 is less than or equal to hours, which is more than 20 hours. I'm sorry, strictly less than hours. That's more than 20. Must be equal to the probability of freshman. And again, if this is empirical data, I really should add this idea to it. Okay, well, let's see what we can find out. Probability of freshman is 66 over 280. So let's see, this is 66 divided by 280. Now, what's the probability of a freshman given more than 20 hours? Well, Let me clear this off. Given more than 20 hours, says this is my entire universe. What's the probability of a freshman? Well, that's 17 out of 104. So let's go back here. This conditional probability is 17 out of 104. So I'm saying that 17 out of 104 is actually equal to 66 over 280. That's assuming that they're actually independent. Well, rather than reaching for a calculator and quickly going for decimals, I recommend you don't do that. Because if these ratios are close, they could be equal out to a couple of decimal places and then be different, and you might miss that. So use cross multiplication. If these are equal, then 17 times 280 must also be equal to 66 times 104. Now, go ahead and do this in your calculator, and what you're going to find is that these are not equal, that they're actually not equal. So if this is not equal, then this is not equal, then this is not equal, which means the two events are not independent. If they're not independent, then they must be dependent. Two events only have two choices. Either they're independent of each other or they're dependent of each other. That's the only choice that it has. If these probabilities turn out to be equal, then we come back up and say, well, yeah, they must be independent of each other. Okay, let's take a look at another example. School administrators are proposing a change in the academic calendar. 60 students were surveyed, and they were asked if they preferred A shorter Christmas break by 1 week, which would result in a longer summer break by 1 week, or B, a longer Christmas break by 1 week, which would result in a shorter summer break by 1 week. The results are shown before. So, event A, this is the shorter Christmas break, right? So I'm going to put shorter. And event B is longer Christmas break. And then we broke this down by juniors, sophomores, freshmen, sophomores, juniors, and seniors. So, are the events senior and option A independent of each other? Knowing that somebody was a senior, that tells us what they probably chose in terms of the option, or knowing that what the option is, well, that would tell us whether or not they're seniors. Well, we can work this out. Don't try to work it out intuitively. I mean, that's a good place to start, but that's not going to be, that should never be your answer. So, let me see. The probability of senior given event A must be equal to the probability of senior if they're independent. Well, the probability of senior given A, that means this is my total universe. There were 4 seniors, so that's going to be 4 out of 20. Now, what's the probability of a senior? Well, let me erase this. Here's my seniors, and 9 out of 60 were seniors. So this must be equal to 9 out of 60. So that can only happen if 4 times 60 equals 9 times 20. 4 times 60 is 240. 9 times 20 was 180. These are not equal. Therefore, these are not independent. If not independent, then they must be dependent. So, knowing that somebody is a senior will actually have an effect on the probabilities based on this information as to whether or not they selected A or B. And once again, as a point, because this is a sample, I guess we really should remember to put those hats on there because these are sample probabilities. All right, here's the same situation, same data. Are the events freshman and option A independent? Okay, well, if independent, then the probability of a freshman given A will equal the probability of a freshman. Okay, so probability of freshman given A. Well, here's event A. There's 5 freshmen, so that probability is 5 over 20. And let's see, what's the probability of a freshman? Probability of a freshman, right here's a freshman, there's 15 of them. That's 15 over 60. So are those equal? Well, if it is, that can only happen if 5 times 60 happens to be equal to 15 times 20. Well, 5 times 60 is 300, and 15 times 20 is 300. So they are equal. Therefore, the conclusion is that the events freshman and event A, which I believe was the shorter Christmas break, are independent of each other.